Okay, so welcome to class. I had to post yesterday's blog post a little, just went through last night and it didn't. So there's going to be two posts today. Today we're starting lesson 3, the last lesson of the quadratic equations unit, and the last time that you'll need a graphing calculator for this course, unless you're doing review work, and of course to write your tests if you're going to write the linear test or the quadratics test. So that's kind of nice. Our last unit will be measurement, and it is just involving all different types of measurements and conversions and formulas, so you can use a regular calculator for that, which is nice. Today, solving systems. A system, in the opening statement, a system of equations is when we have two or more equations of functions. So when we enter in two or more equations in the y equals screen, which we've already done that, finding x-intercepts or solving for x values, we'd always enter an equation into y1 and into y2. That actually was a system. Systems get a little more involved, a little more complex, because prior to this, we've had finding x-intercepts. Our second equation is always just a straight line. So now we're going to do systems of equations that can get a little more involved. But the techniques that we've used are going to be the same techniques that we use in lesson 3 to find intersection points. So a system of equations can consist of different types of functions. For example, a system can consist of linear equations, quadratic equations, or we are using where the equations of a system intersect each other. If they intersect, they have some points in common. Therefore, to solve a system of equations, we find the intersection points. Now, we've already done that, and I'm just going to highlight that again. When we had, for example, so I'm just going to do a quick example here. When we were graphing our functions before, and when we were perhaps graphing a linear function, this is my y-axis, this is my x, and we would graph a linear function, for example. Anytime, and when we entered this is our y1 statement, and when we entered our y2 statement in, for example, y2 equals 0, when we were finding the intersection point, we were finding the intersection point of a system, right? The two equations developed into a system. Also, that happened when we, for example, if I gave you the equation of the straight line, this is my y1, and we were asking you to find x when y equals, 8, for example. What we did is we put a y2 equals 8, and we found the intersection point, right? So that was a system. Anytime you had a y1 and a y2, you were developing a system. And then the last type we did, for example, we just talked about parabolas. And then sometimes you would enter a y2 statement in, and I said to you, find the value of x when y is 10 for the second time, right? The intersection point here. This was finding the intersection point of a system, because I was finding the intersection point of the y1 equation and the y2 equation. So we've already worked with systems, but now we're going to put a kind of a more formal name on it. So this is almost going to act as a review assignment. Let's go back to the opening paragraph. We are usually interested in where the equations of a system intersect each other. Okay? And we've seen that already. If they intersect, they have some points in common. Therefore, to solve a system of equations means we're finding the points of intersection. So let's do this first example. There aren't a lot of examples in this lesson, so we're going to do all 3 of them today. So solve the first system of equations given by y equals -2 bracket x minus 3 squared plus 6 and y equals -4x plus 15. All right, this is going to be my y1. This is my y2, just because that's how they appear on the paper. Now, knowing what we know about our equations, I can tell because of there's going to be an x squared here, this is a quadratic equation. So that's going to be a parabola, right? And because my leading coefficient is negative, it's going to be a parabola pointing down. And this will be a linear equation. And it will also be, because it's a negative coefficient, it's going to be trending down. So what I'm going to do is I'm going to graph both of these on the same screen and see where they intersect each other, if they do. Remember, solve the system means, this means find the intersection points. Okay, and we're solving for that the functions intersect. So make sure that you clear your calculator out. I've already done that with mine. And I'm going to move this up a little bit now. We don't need all that text. Okay, I got my calculator here. Just going to focus again. And then I'm going to turn my calculator on. I'm going to go to my y equals screen. And it doesn't matter which one you call y1, y2. I just called this one y1 because it appeared first. So I'm going to move my calculator up so you can see exactly what I'm doing. So I've got a -2 bracket, x subtract 3, close bracket, squared, plus 6. And then I'm going to move to my y2 statement. I have -4x plus 15. So there's my quadratic, there's my linear. I don't know about the windows yet, so I'm just going to wait and see what happens. I'm going to see what I can see from my grid. Oh, there's my parabola. That's nice. And actually, I do see 2 points of intersection. This one and this one. So I don't really need to adjust my windows. Now, all I have to do is find the points of intersection. You remember how to do that? Find the points of intersection. Same way we've always done it. And this, I'm showing my work here. It's second trace number 5. Because number 5 is the command intersect, and that's helping us find our intersections. So second trace number 5. I just want to find my cursor wherever my cursor is, and I don't know where it is right now. I'm looking, there it is, okay. I'm going to do my first one. Now I answer the 3 questions. That's my first statement. My second statement, take a guess. So my first point of intersection is, I'm going to draw a picture of this too. I'm going to draw a little picture here. I should have drawn this a little over more, sorry. They're not asking me for a picture, but just gives me a place to put my answers. Okay, here's my first intersection point. So it's going to be 2.42, comma, 5.32. Okay, that's this point. And now this point over here, I got to go through the same process again. Second trace number 5. Now I have to move my cursor to my second point. And I get 5.58 negative 7.32. Okay. And that's it. It's actually less work than our others, but what we're doing is we're finding our points, our coordinate points of intersection, right? Where if the two functions intersect. Now, they don't have to they're not always going to be a quadratic and a linear. We could find intersection points of 2 linears, 2 quadratics, or a quadratic linear. We're restricted to linears and quadratics though, because those are the only 2 we've studied so far. All right, so let's try this next one. That was just a problem with no context at all. Now we've got a word problem though, so we're going to have to do a little more thinking about this one. Reset my calculator. Okay, let's read the question. Find the possible meeting points if one boat is traveling according to the equation y equals 6x plus 4. That's linear again. And a second boat is traveling according to this equation. Well, this is a quadratic. So I guess one boat is traveling just in a straight line, and one boat is kind of taking a more of an arced journey across the lake. Okay, so let's see if these boats are going to meet at all, because that would be something of importance, right? You want to make sure actually that they're not going to meet, because if they meet, they're going to crash. Okay, I'm going to enter in my linear first, just because it appears first. And then I have 3x squared plus 2x minus 5. Let's see if I can see this one on the screen. Here's my linear. All right, I don't quite see that second intersection point. It looks like it's going to intersect up here, so I'm going to increase my window. That'll be my y max. I'm just going to double up to 20. Here's my linear. Here's my quadratic. I think I'm actually going to increase it even a little more. I'm going to increase it to 30. There we go. Okay, so now I can see them. So it does look like they're going to intersect. Once again, for the equation, or pardon me, for the picture, but I'm still going to draw one. And then this one. So I'm going to find this intersection point and this intersection point. All right, here we go again. Second trace number 5. So I get negative 1.19, comma, negative 3.14. That was the lower one. And I'm going to do the same thing and find so I'm going to get 2.52, comma, 19.14. Okay. And that's it. It looks like those are the two possible meeting points. Are 2.52, 19.14, and negative 1.19, negative 3.14. Okay, now why would this be a problem? Well, we can see in the next example, determine the possible crash points for two aircraft following using the following trajectories. This is a quadratic. So the plane is sort of flying in an arced motion through the sky. This is also another quadratic because of the two x's. When they multiply out, you get an x squared. Okay, so I've got quadratic, quadratic. Could they possibly meet? Well, for sure they could, right? If you think about it, two quadratics could actually meet in a few different formations. Let's see how these two meet. So let's first take a second to clear our calculator out. Okay, so let's see what we get here. Let's move this over. I've got my y1 statement, 3x squared plus 4. And my second statement is bracket x subtract 5, close bracket, and then open another one. 1 minus x, close bracket. All right, let's see what happens. I don't know if we have to adjust our windows yet. We'll take a look. There's my first, my second. Okay, so that clearly shows you can have two parabolas that don't intersect at all. So I would respond, there are no points of intersection So the planes will not crash. Thank goodness, right? All right, so that's it. So very simple assignment. The concept isn't simple though, right? The concept is quite meaningful. Just knowing what solving a system is, that's the big lesson for today. You've got one last assignment to do in this unit before you can tell me you're ready maybe for test, but I haven't had anyone write or complete the linear either, so you're gonna have to do that one as well. So we've got 5 questions. I'm gonna give you the rest of today, and perhaps I'll go through a few of these tomorrow as well. And then we'll be starting measurement. So please, once again, let me know if you have any questions at all about this unit or any previous units. And hopefully I will hear from some of you soon.